Calculus, Unit 7, Day 63. Our objective is finding volumes of solids of revolution using the disk method. A solid of revolution is formed when a flat, two-dimensional shape is rotated around an axis. Consider the flat region below to the left. When that region is rotated about the x-axis, the solid picture below to the right is formed. The objective of this lesson is to learn to find the volume of each of such a solid. Okay, and you might not have been able to see it, but it was going from A to B. And so at point A, there's going to be a circle. So that line right here is representing right that circle up front. So if you look at it from this way, it's just a stack of a bunch of different circles. Now obviously circles get smaller as we get here. And again, we rotate around the x-axis. Then it gets a little bigger when it gets here. And it gets to its biggest point at the end, just happens to be, so that would go all the way down. So that's where you see this circle, and it would be a solid shape, and again, there's an infinite number of circles in here. And I'm rotating around the x-axis, which is the line y equals 0. I could do it at y equals 2, y equals 5. Obviously, the shapes would be a little bit different, but for right now, this is the x-axis. And again, we have to always think that that's y equals 0. Okay, so now imagine slicing the solid into individual disks of height 1 unit. So, and by height, we're talking about this right here. So we're breaking these down into, that's the delta x that we're looking at. So the volume of one of those disks is pi r squared h. All right, so if I had, obviously it's a circle, and think of a cylinder. Any cylinder is base area times the height. So we're now looking at these sideways. So if I went from here to here, it would be pi r squared for the circle, and then the base or the height would be 1. So that's where we get the pi r squared h, or, and since it's 1, just pi r squared. So now if I add all those up, all these disks, again, I add this one with this one with this one with this one. So I'm adding all those up. It would be pi times r, which for right now would just be f of x all squared. But if I did choose to have a different axis of symmetry, it would be this f of x minus whatever that value is. Like, let's say that's 3. So it would be f of x minus 3 all squared. If it was down here at negative 4, it would be f of x minus negative 4, because it would be longer. It would go to the 0, go down there, and then we'd have to repeat the length of the radius on the other side. So fx minus whatever the axis of rotation is squared, that's our radius. So that's the pi r squared, and then this dx actually ends up being the height. Okay, and we said it was 1 before, but depending on what that is, and we're going to have an infinite number of those. Okay, so the sum of all those disks is the same as the volume of the solid. So let's now look at an example of this and what it's going to look like. So notice that the axis of rotation is the x-axis, and the bottom function of the region is also the x-axis. Imagine for a moment what the solid would look like if the axis of rotation were still the x-axis, but the bottom function of the region was the line y equals c. So I kind of started to give that example. This is going to be, you can't really see it there, y equals c. And then all we're going to do is we're going to take, and here's my f of x in red, but we're just going to take this and rotate that around the x-axis. There's the x-axis, which is y equals 0. So the solid would look very similar to what we had up above, except there's going to be a cylinder cut out of the center. So we'd rotate this around, and then there'd be a little blank spot, and then there'd be the blank, and then we'd rotate it around. And then same thing all the way through, copying with this function, maybe, I didn't do it steep enough. So if we were looking from this direction, it would be this hole cut out all the way through, and that would be the shape of a cylinder. So to find the volume of this solid, We would find the volume of the whole solid that we just found up above, and then subtract out the solid in the form of a cylinder, and we would use this. So it's the outer function minus the axis, which in our case is y equals 0, minus the inner function minus the axis, which is c, so c minus 0, all squared at dx. Okay, and when we talk about outer function, inner function, it's always the outer is the furthest one away. Okay, so that's the furthest from the axis of symmetry. And our volume would be equal to pi, which is a constant, so we can bring up front. The integral from a to b of f of x minus 0, so that's the outside function furthest from the axis of rotation. 0 is what we're rotating around, minus c minus 0, and again, that's the inner function because it's closer to the axis of rotation. C minus 0, and again, that 0 is still our axis, which is up here, and that's all squared, and then dx. Okay, so we're going to take a look at some of these on part 2. And there's one example that rotates around the x-axis and one that rotates around the y-axis. All right, so that's part 1.